my dear students, welcome back to my class. In the series of learning data structures through C, in the previous video we discussed about queues. We saw the introduction to queues and how actually the queues are represented. We learned the ordering principle of queue, that is the first in first out concept, and some features of the queues. Well, in today's video, we will continue with the same topic, queues, and we will see what are all the operations we can perform on queues, and also the values with respect to the two pointers that what we use, front pointer and rear pointer, and how it is used to store the value and to access the values. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Let us understand the operations on queues. So what are all the operations we can perform on queues? So the operations that what we have is the first one, which is queue. So what actually this queue, the first operation says? So it is going to create a new queue, an empty queue. So it is going to create a queue that is empty. Then is empty. The name itself tells you it is the function that is going to check whether the queue is empty. NQ and DQ, the most important operation. NQ says it is just like push operation. So we are going to add a new item to the queue from which end? Rear end. So this we have discussed in the previous video, what actually this rear end and front end is. So NQ says you are going to add a new item. So you have the queue, and when I say I am doing the NQ operation means I am doing the insertion operation, nothing but push operation that what we had in stack. So when I say NQ means insertion or push. So I have to enter the item from the rear end, or what we call it as back end. So from back end we do the insertion and the element will be placed to the first position if the stack or the queue is empty. If the queue is empty, say you just imagine the counter is free. No one is standing in the counter, ticket counter. And when you enter into the queue, you will be the first person, right? So you will be standing in this first position. Then once again when I do NQ, the next item or the next person will stand next to this one. So I am just writing the index values. So like this, I go on doing the insertion, and when the counter is filled, then I just can't do the insertion. The same way when I say I am entering the items, I am storing the items into the queue. The first item will be placed to the 0th position, the next, and next. When it reaches the queue size -1, then the queue is full. So NQ is stopped. Then I can start doing the DQ operation, where DQ says you remove the item, you delete the item. It is deletion. So what is DQ? It is deletion, similar to pop. But here I need to remove the item from the front position. So that is what we say. It is insertion and deletion at two different ends. Whereas in stack, we do the insertion and deletion from the same end, that is top end. So the first person or the first element which is stored in the queue will be the first to come out. So it is first in, first out. First element inserted will be the first to come out. First in, first out. Then say 20, then 30, 40 and 50. So here one thing that what we need to observe is in NQ we insert and DQ we delete. Both these operations are done in two different ends. One is the insertion, so-called NQ, from the rear end, and the DQ, so-called deletion, from the front end. NQ from the rear end and DQ from the front end. And how these values of front and rear we are going to manage, let us understand that with the values of front and rear. Okay. Then size. It is going to just return the number of items that what we have in the queue. So and now just go through this queue. So the queue is full now. So what is the total size? It is 1, 2, 3, 4, 5. So the queue size is 5. The same way when I do the deletion, I can delete all the 5 elements. So when I delete all the elements, the queue becomes empty. How I can understand these values? That is, whether the queue is empty, whether the queue is filled with values, what is the status of the front pointer, what is the status of the rear pointer. Let us understand that with the values of front pointer and rear pointer. So this is with the operations on queues. Now let us understand the values of front and rear. So let us understand the values of front and rear. Initially, the front and rear pointer will be initialized to -1, or what we can call it as null. So when the front or a rear equals to -1, or what we can call it as null, then the queue is empty. The queue is empty. And then when we start inserting the elements into the queue, we need to insert the elements from the rear edge. So I just say rear equal to rear plus 1. So it is -1 plus 1, which is equal to 0. So the rear will be pointing to 0. Then I can start inserting the elements. So what I can say, now I am inserting the element 10. So when I say rear equal to rear plus 1, it is nothing but I am performing the NQ operation from the rear edge. So when you enter the queue, you don't start at the first position itself, right? You enter into the queue and you go to the first position. That is what. So I say rear equal to rear plus 1. So it is -1 plus 1. It is 0. I'll come to this position. Then once again it goes on, rear equal to rear plus 1. So it is 0 plus 1. Then 1. Again 1 plus 1. 2. 2 plus 1. 3. 3 plus 1. 4. So from the rear end, so it is rear equal to rear plus 1. I go on doing the NQ operation. NQ means inserting the element into the queue. Then I say rear equal to rear plus 1. So it is 1. Then again 2. Then 3. Then 4. So I will start entering the elements. When the rear pointer equals to queue size -1. When the rear pointer equals to the queue size -1. So for example, the queue size is 5. So it is 5 minus 1 means 4. So queue size -1. Queue size is 5. 5 minus 1, it is 4. So when the rear pointer, so rear increases, it will go to, as I said, 1, 2, 3, 4. Finally, the rear will be pointing to 4. So when the rear equals to queue size -1, that is 4, it says the queue is full. The queue is full. So when the rear, see, we increase the rear pointer. So I increased -1 plus 1, 0, then 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. Now the rear is pointing to 4. I also entered the element. Then when the rear pointer equals to queue size -1, so it is 4. So rear is 4. 4 equals to 4? Yes. Then I get a message, queue is full. Then what I can do? I can do the DQ operation. Right. And front will be -1, or sometimes in some algorithm I can also say front can be set to 0. It can also be set to 0. So now the front pointer will be here. Front pointer will be here. First position. I say the first element will be removed. So -1 plus 1, or it can be -1 also. -1 plus 1, I will say -1 plus 1. Front equal to front plus 1. -1 plus 1. So it is 0. So -1 plus 1, it becomes 0. Front will be pointing to 0. This element will be DQ'd. So when I say front equal to front plus 1, it is DQ operation. DQ means removing the item from the queue. See, again I have to increase that. So it is again front equal to front plus 1. So it is 0 plus 1. Front will be pointing to here. Remove this. Again 0, 1 plus 1, 2. Again remove this. Then 3. Remove this. Then here. Remove this. Right. So when I increase the front pointer, it is DQ. When I increase the rear pointer, it is NQ. Don't get confused with NQ and DQ. Sometimes we will have that confusion. So you can just have a brain remembrance. DQ, D, delete. NQ means insertion. For NQ, we enter from the rear end. So it is rear equal to rear plus 1. DQ means deleting. It is front equal to front plus 1. So when the front and rear becomes the same value, then I can just say there are no items in the queue. And I need to reset the front and rear pointer to -1. Then front and rear becomes -1. Again, the queue is empty. So this is with the front and rear values. Remember these values because we have to use these values for the algorithm. For the algorithm purpose, we need to use these values. Front and rear pointer is very much essential. If you don't understand this front and rear values, you cannot understand the algorithm. So front and rear values are very much important. When I increase the rear pointer, it is NQ. When I increase the front pointer, it is DQ. And one thing you need to notice here in this Q operation, we always do the increment of both front and rear. See, whereas in stack, we have only one pointer, top. When top pointer get increased, it is push. When top pointer get decreased, it is pop. But here, we do the insertion and deletion at two different ends. One is rear end, the other one is front end. For insertion, so-called NQ, we increase the rear pointer. For deletion, so-called DQ, we increase the front pointer. For insertion, rear pointer gets increased. For deletion, this front pointer gets increased. In both the cases, it is incrementation only because we have two different pointers. Rear pointer increase, insertion. Front pointer increase, it is deletion. So this is what with the front and rear values. Hope you have understood with this. In the next video, we will see the memory representation of queues. Stay tuned to my channel. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.